And welcome YouTube to our deep dive into space weather. We've got a period of geomagnetic unrest happening once again. And the first thing we'll look at is Magneto hydrodynamic pressure over the past 4 hours. We're going to let this play through twice. I would remind you that the reason that we make these videos is not because I jumped on some sort of a space bandwagon. I've been studying things like cosmic rays since about 1981. Maybe 1980, something like that. I learned to read at age 3, so I didn't have to go to school. They made me go anyway. And in the mid-90s, I realized I needed to do a deep dive into heliophysics. I thought there'd be some breakthroughs between now and then. And frankly, well, there have been some. There have been some breakthroughs between 1994 and now. However, we think we've explained the mechanism underlying the solar sunspot and solar polar field reversal cycles. This is what the Magneto hydrodynamic pressure looks like around planet Earth during geomagnetic unrest periods. High pressure environment. So we do see some aurorae happening here. It looks like we are seeing a coronal mass ejection strike from the X-class flare we saw a couple of days ago, right around when we were expecting it to happen, today on April 2nd. So there's your auroral forecast. And we're not expecting this to last super long. There could be some coronal hole high-speed wind streams mixed in with this coronal mass ejection strike. We'll get to more data on that momentarily. It looks like things may be subsiding here in the past couple of hours. Here are ground magnetic perturbations. We showed you Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. The scale here is nanotesla as opposed to nanopascals. And like the magnetic moment from space, that's the last 4 hours of ground magnetic perturbations. Again, it looks like the CME influence is slowing down. It's subsiding. Next, we're going to look at cosmic rays, as we haven't shown them on the channel for a while. Here is the Apatity neutron monitor, and you can see a downtick in cosmic ray flux over the past 30 days. A slight downward trend happening there at Apatity. At Barentsburg, a similar downward trend in cosmic ray flux, low the past 30 days. Let's go farther south to Athens, Greece. Interestingly, Athens showing an uptick in cosmic ray flux. And for you new viewers out there, cosmic ray flux is the flow of incoming particles from deep space. Distant galaxies, distant stars are able to get particles all the way to the surface of the Earth. When that happens, as those particles descend lower and lower into Earth's atmosphere, the likelihood of then bumping into things becomes higher and higher. They can create radioactive isotopes, particle showers, and they seem to be sort of important when it comes to solar sunspot cycles, in that cosmic ray flux is inversely proportional to the sunspot number. And this is something that we see apparently going back a long, long time. Anyway, once again, the Athens neutron monitor showing a bit of an upward trend there over the past 30 days, which is interesting. Let's go farther south to Mexico City. A slight downward trend there at Mexico City. So there's some disparities, and indeed different parts of the Earth see a different cosmic ray flux profile. As magnetic fields do affect the path of these particles, it's very difficult to detect where they come from. One of the only known sources is Alpha Cygni, a star known as Deneb, the most intrinsically bright object visible from our solar system. Next, going a little farther north once again, really far north, to Oulu, Finland. There's Oulu's neutron monitor, and you can see a downward trend at Oulu over the past 30 days. There you go. There's that slight downward trend at Oulu. And we'll also take a look at the farthest south locations we can find, DOMB and DOMC Antarctica. Major downward trend at DOMB Antarctica, and similarly significant downward trend at DOMC Antarctica. So that's our cosmic ray report. If you don't follow us on Twitter, perhaps you should. We've got countless incredible auroral shares, retweets on Twitter, twitter.com/smashamash. If you ain't got an account on Twitter, get one. I don't care who's banned. Get on Twitter anyway. It's important for people to maintain the vestiges of civilization. So we did see a brief period of geomagnetic storm here And we've been mostly in geomagnetic storm or geomagnetic unrest over the past 3 days. That's the KP index, a measurement of global geomagnetism. So I think we're seeing this subsiding at the moment. Let's take a look at some more data like the real-time solar wind. And if you look at the speed and density, this looks like a weak coronal mass ejection strike. So perhaps a glancing blow there. Doesn't look like a real direct hit, as we only saw a minor increase in the density and the speed. There's also a signal showing up here in the plasma temperature. So that looks like a weak coronal mass ejection strike. It was associated with that X-class flare. And let's see where the conditions got to here. We did see speeds make it all the way up to, come on now, come on active applet. We did get speeds all the way up to about nearly 600 kilometers a second. Density only about 13 protons per cubic centimeter, but that certainly looks like a CME strike, because when we see the density and the velocity come up at the same time as we did here, that does not look like a coronal hole high-speed stream. Anyway, current conditions are about 10 protons per cubic centimeter for the solar wind density, solar wind speed about 540 kilometers per second. Proton event is subsiding, so we're almost back to background proton flux levels. Following this proton event, which is associated with an X-class flare, those relativistic particles took their time, and there are some theories as to why that happened. Again, follow us on Twitter to find out more about that. GOES magnetometers here showing some quite low readings here, and some quite sawtooth patterns happening, probably associated with the arrival of the coronal mass ejection that we're seeing now. Also some changes happening to the heliospheric current sheet. So let's take a look at that. We were expecting to see a North Pole current sheet showing up at Earth, and now not. Let me reload that, as it looks a little funky. So we were expecting this North Pole current sheet shown right here to make it to Earth. It has not done so. And that's causing me to think that we're going to see some activity in the south, or some weakening of sunspots in the north, or perhaps a combination of both. Keep in mind that data is nearly 2 hours old from when we recorded the video. Here's the line of sight view, also showing the solar magnetogram. I'm going to refresh that too. Line of sight, ecliptic plane field plot shows the solar magnetogram. And I think we may be seeing some increase in the activity in the northeast. So we do see an active region rising as well in the southeast. We'll get to that. Let's reload this one as well. Here's a line of sight coronal hole plot. A bunch of South Pole oriented coronal holes here showing up on the east side. There you can see those red areas. Those are South Pole oriented coronal holes. This also shows the sun's B field in blue. Next, looking at coronal holes visually using 193 angstroms from the Solar Dynamics Observatory, my favorite telescope. And I think we're going to see a rise in activity up here. Maybe this active region rising down here isn't a sunspot, or maybe this one is going to become spectacularly beefy. That's my forecast. Let's move on to sunspots. And it is quite a large umbra there, so that could be affecting the polarity of the earthly heliospheric current sheet. Sunspots have been largely stable over the past 24 hours. Nothing too exciting going on there. We are seeing the setting of sunspot 2975. Don't be surprised if you see that thing rotate all the way around. In about 25 days, we may see it rise again. Something like 3 weeks from now. One of the most exciting sunspots so far during the exciting solar cycle 25. Let's move on to solar flares. Likelihood of major solar flares, very high. We saw one M-class flare throughout the last 24-hour period. Likelihood of additional ones, again, very high. Don't be surprised to see radio blackouts, additional coronal mass ejections. There are huge filaments associated with these active regions right down here. Sunspot 2981. And remember, folks, As sunspots approach the limb, they're actually more likely to produce large flares. There is a little bit of a correlation between being near the limb and producing large flares. If you enjoy the content, press like and subscribe. Tell your friends and foes about us. Did you know that we're on BitChute as well? Yeah, we've got exclusive content on BitChute most days. And we're getting like 2,000 views a day over there. And mysterious view numbers on YouTube, where we see videos that have a view count that goes from 500 back to 467. That makes a lot of sense, right? Unviewing a video is about the same as a negative distance. It's not a thing. We also stream regularly live to Twitch. Thanks to our Twitch followers, consider clicking our links. You can find some sweet merch at Smasho Merch right there, that link. Welcome to the Neo Renaissance. We haven't forgotten about writing a paper explaining the solar sunspot and solar polar field reversal cycles. Help us out by becoming a member of the Smash team. Gold and silver members will see some additional content nobody else gets, like our GDAX daily reports. Smashamash.com/Smash team. Support the channel that way. We still do have Patreon as well, but if you want the additional content, Smashamash.com/Smash team. Here's the M-class flare that we saw, the largest flare of the past 24 hours. Peak flux was right around 3 o'clock this morning. It did not produce a coronal mass ejection. We'll show you how it didn't. It came from sunspot 2975. And right there you can see that M-class flare. It's becoming less newsworthy as solar cycle 25 ramps up in spectacular fashion. Are we seeing a grand solar maximum? Are we just seeing a regular, old, everyday, normal, decent-sized sunspot cycle? Let us know in the comments what you think. Thanks to everybody, all of our new viewers who've been leaving comments. We do read them all. We can't respond to them all, but we do read them all, and thanks again for that. We appreciate the interaction, and we consider these videos a collaborative effort. Next, looking at the solar system here, we're going to show you a one-week forecast. There's where things will be in a week. We'll be moving into a gibbous waxing moon in 1 week as Mercury swings around the far side of the sun. And let's bring up a star chart real quick. Venus, Saturn, and Mercury. Venus, Saturn, and Mars, rather, rising ahead of the sun. If you're up before dawn, you may see that great planetary pileup up there. Those bright objects are Mars, Saturn, and Venus. Venus, the third brightest object in the sky. And let's move on to coronal mass ejections. We ain't got none, despite that M-class flare. Remember, folks, we don't need sunspots to see coronal mass ejections, and we don't necessarily see coronal mass ejections with flares. Here's the view from L5, Lagrange point 5 and Lagrange point 1, the locations of the stereo A coronagraph and SOHO-LASCO C3. There you have it. Mercury showing up there on the right imagery. And it looks like we have a little cosmic ray streak there showing up, striking the aperture. Where did that cosmic ray come from, folks? Did it come from Deneb? Where did it come from? Who knows? The answer is we don't know. Although we do know that Deneb, aka Cygnus X3, is one of the only known, if not the only known, point source for cosmic ray flux. Anyway, that's where we'll close out the video. No CMEs showing up on the coronagraph imagery, but one showing up here in the Earth geospace. Thanks for tuning in to the Daily Space Weather. Congratulations on realizing the channel exists. We value you as a viewer, and we would like you to understand the physics. So help us out. And we'll talk to you soon here at the Smash News Network, least busted name in news. May that solar wind be at your back.